In this video, we're going to talk about BACnet wiring and settings for the VCCX2 controller. First thing we'll talk about is the different flavors of BACnet. Currently, there's the BACnet MSTP, which is an RS-485 method of communications. First off, MSTP stands for Master-Slave Token Passing. However, many people use this terminology to describe 18 gauge shielded twisted pair or twisted pair type communications. So this term generally is used to describe the communications loop using a shielded twisted pair wire. And there's a picture of that type of wire. Typically, you're going to require MSTP routers. Now, the other form is called BACnet IP. IP stands for Internet Protocol. It's the same protocol that you use to connect up to the internet or your computers use on a network within a facility. Communications information is going to be passed between controllers using a package using the IP base. So all the information for BACnet will be put into a block within an IP packet on the network so that it can travel with the other information on the IP network within the building. Typically, you're going to use Ethernet connections for this type of communications. And so there's your standard Ethernet connector. And typically, standard routers are going to be used during that time. So VCCX only has MSTP BACnet available at this time. That connection can be found right here on your VCCX2 controller. So to continue on, we need to talk about some of the rules having to do with MSTP BACnet wiring. First rule I like to think of is the wire type. You've got to use shielded twisted pair wire with less than 30 picofarad capacitance per foot. All paired wires or all cables with multiple conductors will have a capacitance reading because all a capacitor is are two conductors separated by an insulator. Anytime you have that, you have capacitance. So what we need is shielded twisted pair wire with less than 30 picofarad of capacitance per foot. Now, most of your supply houses, if they supply other things other than cable, they might not know what you're looking for here. So the best thing that I can give for advice is to ask for standard BACnet MSTP wire, and usually they will have some of that in stock. So the wire gauge is not super critical, but I do recommend that you go no smaller than 24 gauge stranded wire and no larger than 18 gauge stranded wire. The reasons for these numbers is so that you have some mechanical stability to your wire. Most of the time these controllers are going to be mounted inside of a piece of HVAC equipment, which does vibrate quite a bit. So you'll need to have something that can handle those vibrations. And on the other side, you don't want to go too big because then it becomes too difficult to work with the wiring when you're connecting it up to the smaller terminals on the controllers. The second rule is the connection method. You want to connect each controller in parallel, plus to plus and minus to minus, using the twisted pair wire. So inside of your cable, you're going to have a twisted pair or two conductors with insulation on them, usually two different colors of insulation. You're going to choose one of those for the positive and one for the negative. So if you had white and black, you might choose white for positive and black for negative. And you're going to connect those in parallel to each of the controllers. You need to wire this in a daisy chain format. So you're going to go from one controller to the next controller to the next controller, so on down the line. You really do not want to add any T's or stars into the configuration. You really just want to go a daisy chain format, even if you have to go a little bit longer with your wire. The longest that you're allowed to run your communications wire is a total of 4,000 feet. That is if you follow all of the rules that are being mentioned in this presentation. You do not want to loop the wire back to the first board. So when you get to the end of your daisy chain, you do not want to loop that wire back to the first controller. This is not a ring. This is a daisy chain. So do not loop that wire back to the first board or connect it up back to any board that's already connected. The next rule has to do with shielding. Now you're going to take the drain wire, which is your bare conductor within that cable, and you're going to tie it to the earth ground in one place only. So the chassis of the building is a good example of that. So inside of your rooftop unit, that chassis of that unit is tied to earth through the power coming to the rooftop unit. So if you tied it to the chassis of that unit, that is going to give you an earth ground for your drain wire. And you only want to do this in one place on your communications loop. If you connect it in multiple places, you can get some additional noise introduced into your communications wire. The easiest way to do this connection is just to tie it right to the shield terminal on the VCCX controller. So on your BACnet connector, you're going to have three terminals on it. You're going to have the plus, the shield, and the minus. So if you were to tie the drain wire to that connector on one of those boards, that would give you a chassis connection to the unit. The drain wires for the rest of the boards at each of the termination points for those wires, in other words, where you go into the controller, you're not going to connect it on every controller. What you're going to do is just take the drain wire, twist them together, and put a wire nut on them so that the connection for the shield or the drain is just tied to earth in one spot on that first board. All of the rest of the points are just going to be passed through the cable. If you have a device such as a router that has isolated communications, what they do is they will isolate the communications sections so that no extraneous voltages or anything like that won't damage the router. So if it does have isolation on it, it is highly recommended that you tie the isolated device shield to that board, and then when it connects up to the first controller in the line to the shield terminal on that, it's going to pick up a common ground between all the boards. And I'll have an example of this coming up here shortly. So as I mentioned, this is going to provide a common ground to that isolated device. The fourth rule is termination. There must be a 120 ohm resistor on each end of the communications loop, and it does need to be the very first controller and the very last controller. This is going to connect between the positive and negative terminals. It's just going to go right across them. So in your first board, you're going to take a 120 ohm resistor and put it across T and plus and minus, and then on your last board you're going to connect it between plus and minus. Biasing resistors is on rule 5. Now there must also be a 510 ohm resistor tied from the plus terminal to a 5 volt source or a 5 volt DC source. And there must be another 510 ohm resistor tied between the minus and the common 24 volts or the 5 volt common. Now typically this is going to be installed already on your router. So I would recommend that you look for routers that already have the biasing resistors built into this. A lot of times they'll even have the first termination resistor in there as well. And in some cases you may have to flip some switches or set some jumpers, but most routers will already have these installed. I strongly recommend you get this type of router because accessing 5 volts from for the external resistors is not always easy in these applications. So if you already have a router, if you need a router, and if you can get one that already has those resistors built in, it's one less thing you have to worry about. So here's an example of what we've talked about. In this case, we have a router, and on the router it's got isolated communications, and in that you've got your minus and your plus, and then you've got a shield connector. Inside of that router you have a resistor already built in going from the positive to 5 volts and from the negative to ground. And then externally, we put a 120 ohm resistor between the positive and negative. Now, since this is isolated communications, we took that shield or the drain wire and we connected it up to the first board. Now, the rest of the loop also needs to be connected to the chassis or to the ground of the board. So that's why this is connected here as well. So these two wires are going to go into the shield. This wire right here provides the common point for this communications. Now it's still isolated from the rest of the router, so it's not going to damage that. But this is going to provide a common point for the communications on the RS-485. And then you've got your minus and your plus terminals on there as well. Now those get daisy chained to the first controller. Now what's different here is you'll notice that that drain wire is just twisted together with a wire nut. Went to the next controller, it did the same thing. And at the end, we did not connect up the drain wire to that last controller. What I would recommend doing is just wrap it around your jacket of your cable and then to take some electrical tape so that it doesn't short to anything and just wrap it up there. And then you're going to take a 120 ohm resistor between the positive and negative once again at the end. So we have one at the beginning, one at the end. So here's an example of what your system's going to look like. This is a very basic system with a router and two VCCX controllers. Now this communications loop right here is called the MSTP network. This is where you're going to have your shielded twisted pair wire tying all the controllers together to your router. And then you can have up to 127 controllers, VCCX controllers on this loop. Now if you have other manufacturers of equipment, you can also tie it into these loops as well, as long as you follow the same addressing or MAC addressing rules that we'll be talking about a little bit later. So here's another system. In this case, we have two routers. We have a router over here, and this has up to 120 ohm or 120 controllers on it. This is one MSTP network. And then we have another router over here with up to another 127 VCCX controllers. Now what's going to make these tie together is this loop right here. And typically on modern systems, this is going to be BACnet IP. So it's going to use the Ethernet cables to tie the routers together. This is going to be what you're typically going to see in today's systems. So now let's talk about some of the settings that are required for BACnet MSTP. So the first setting that's required is the MAC address. Each controller on an MSTP network must have a unique MAC address. Now, this includes the router. If you go back to that previous screen, you'll remember that there's three devices connected up to each of those loops. You have two VCCX controllers and the router. So all three of those have to have a unique MAC address associated with them. The MSTP BACnet MAC address technically can range between 0 and 255. Master devices must be addressed between 0 and 127. Slave devices, which we're not going to be discussing, but slave devices will address between 128 and 255. All of our controllers, all the VCCX controllers, are always going to be master devices, so they're always going to have a MAC address somewhere between 0 and 127. And on our controller, you will not be allowed to set it any higher than 127. So here's an example of that. Here's our simple system again. We've got two controllers and a router. So I've set the first controller to MAC address 1, the second controller to MAC address 2, and the router to MAC address 3. Now I'll talk about why I did this numbering scheme a little bit later in this presentation. But for now, I just want you to see that all three of them have unique MAC addresses. So the next setting that we need to talk about is the device ID. Each controller on a BACnet system, this is all loops or all router loops that you have combined. And if you have additional jobs or buildings, all devices on a system must have a unique ID. So the VCCX2 allows device IDs to range from 0 to 4,194,303. Now, I would advise that you don't use that top number, ending with 303, and you don't go any higher than 302. So the highest that I would recommend is 4,194,302. So here's an example with the device IDs added into the scheme here. So in this case, we have two routers. Each router has a MSTP loop on it. MAC address 1, MAC address 2, MAC address 3. We have another router, MAC address 1, MAC address 2, MAC address 3. They're on different MSTP networks, so these can be the same as these on the MAC addressing. However, the device IDs have to be different across the entire system. So we have the ID 101, 102, 201, 202. So they're unique numbers. This is a valid addressing. The next setting that I want to talk about is the baud rate. All controllers connected to a particular router must have the same baud rate. I would strongly recommend that you set all of your MSTP networks to the same baud rate, regardless of what you use. That way it reduces confusion for future technicians working on the system. We allow for the following baud rate settings in the VCCX controller, ranging anywhere from 9600 all the way up to 768. Now, we recommend that you stick with the default of 38.4. The reason for this is because this is the fastest that BTL certification requires all BACnet devices to communicate at. So if you were to set it up to, let's say, 57.6, and then you add a device to the system in the future that is not capable of talking to 57.6, then you'll have to go back and change all of the settings back down to 38.4. So I would recommend that you set everything to 38.4 unless you specifically need that higher baud rate. Now there's one last setting that we need to talk about, and it's called max masters. All master devices, and remember the VCCX controller is always considered a master device. So all master devices must have a max master setting built into the controller for the BACnet. This tells the controller how many master devices are on the system so that it allows for more efficient communications. The VCCX2 controller's max master setting is hard-coded to 127. It is not required by BTL to make this adjustable, so we have chosen to make it hard-coded to 127. It is, however, required to be adjustable on all routers, and this is going to make a little bit more sense as we go through the recommendation section next. So all of our controllers, all master devices must have a max master setting. The VCCX controller is hard-coded to 127, which is the largest number for the max masters. Now here's our recommendations for setting up the MSTP BACnet using VCCX controllers. So first off, you want to wire the controllers up as we described in this presentation, following the general rules of RS-45 communications wiring. Set the first VCCX controller's MAC address to 0 or 1, and I'll come to that why in just a few minutes. So you're going to set the VCC, if you had 4 controllers, you're going to set them up starting with the VCCXs. You're going to set up all the additional addresses consecutively, or all of the additional controllers consecutively. So then you're going to end the loop with the router. Now it doesn't physically have to be at the end, but the address of that router should be the last address in the loop. So here's an example of that. VCCX2 controllers, MAC address 0 through 3. So 0, 1, 2, 3. And then the router at MAC address 4. Then you're going to go into the router and you're going to change the max master setting on the router to its own MAC address. So if you've set that router to MAC address 4, you're going to set the max master setting in that router to 4. And then I again recommend that you use a baud rate of 38.4 for the MSTP loop. So let's kind of go over what we just talked about here. We've got a loop here of 4 VCCX controllers and a router. We're going to set up the MAC addresses for those controllers starting at 0 and go through 3, 0, 1, 2, and 3. Then we're going to set the router to 4, the next one in line. Remember, the VCCX controllers have a max master setting hard-coded to 127. However, the router is adjustable, so we're going to set that max master setting in the router to 4. Why we do this, or why we recommend this, is it will make your communications as efficient as possible. The way the communications works on BACnet, on the MSTP, is each of the master devices take turns communicating. So it always starts at 0 and goes all the way up through to the last address. Now the board with the last address, before it passes its turn on to the next device, will always look at the max master setting. If that max master setting is the same as its address, so if that token was here at the router and it needs to pass the token on to the next board, before it does that, it will look at its max master setting. If it's the same, then it goes all the way back to the beginning. However, if this was set to 127, then it would try to talk to 5, and then 6, and then 7, all the way down the line, and it will slow the communications network down. So the best thing to do is to set up the system like this, where you have your max masters on your router set to the last address. So that concludes the basic of the wiring and the settings for the BACnet MSTP as we use it on VCCX2 controllers.